Hi, welcome to this tutorial session. Here we have the exponential equation 9 to the x plus 15 to the x is equal to 25 to the x to solve for x. How do we do that? Let's write it again. 9 to the x plus 15 to the x is equal to 25 to the x to solve for x. Okay, the base here is 9, the base here is 15, the base here is 25. So how do we solve for x in this type of exponential equation? Just watch carefully and you will see the reasoning along. Okay, we can see that in 15, 15 can divide by 5 and 9 can divide by 3, and 25 can divide by 5 and 9 can divide by 3. With that reasoning line, we can just go ahead now and divide all through by 9 to the power x. Okay, so we will divide here by 9 to the power x, divide here by 9 to the power x, divide here by 9 to the power x. We obtain 9 to the power x cancels. We obtain 1 plus, all of them have the same power, so we have 15 all over 9 all to the power x. All of them have the same power, 25 all over 9 to the power x. Now, 15 all over 9, there is a common factor which is 3. So we have 1 plus 3 there 5, 3 here 3. So 5 all over 3 to the power x. Here we can see that 25 is 5 squared and 9 is 3 squared. So to come up with something uniform, so we have 5 squared all over 3 squared to the power x. Okay. All right, so we apply the power of power laws. We're going to have 1 plus 5 all over 3 to the power x is equal to, the powers are the same, so we have 5 all over 3 squared, all of that to the power x. Power to the power law again, we have 1 plus 5 all over 3 to the power x is equal to 5 all over 3 to the power, we multiply out this power, 2 multiplied to x, it gives us 2x. So our exponential equation is now transformed to this. This equation is the same as that, mathematically speaking. So what do we do next? We can see 5 all over 3 being raised to the power 2x. Can we rearrange that so that it has the power 2 outside? Here the power was inside. Let's just swap positions. X come in and 2 go outside. So we have 1 plus 5 all over 3 to the power x is equal to 5 all over 3 to the power x squared. Okay, so we just simply swap positions here. The x goes in and 2 comes out. Okay, so we can quickly see a quadratic gradually coming up, a quadratic expression in terms of 5 all over 3 to the power x. Okay, so let's bring this expression from the right hand side to the left hand side. We'll have 1 plus 5 all over 3 to the power x minus 5 all over 3 to the power x squared is equal to 0. That is our quadratic expression gradually coming up in terms of 5 all over 3 to the power x. Okay, so if we now let a new variable y to be 5 all over 3 to be 5 all over 3 to the power x. Okay, so we're going to have this expression will be transformed into 1 plus y minus y squared is equal to 0. You can see the quadratic expression which is gradually coming out. So to arrange it very well, since we want to work with positive coefficients or whatever, you can still work with it as such. You can just go ahead and work with it as such. This is our square expression, this is the y expression, and this is the constant. So from here we have this quadratic equation, from whence we now collect our quadratic coefficients. We have a is always the coefficient of the squared term. The coefficient of the squared term here is -1. B is the coefficient of the y term, the coefficient is 1, and C is our constant. So after collecting this, we now apply the quadratic formula. Remember here is in terms of y. So we say y is equal to minus b plus minus the root of b squared minus 4ac, all of that divided by 2a when we apply the quadratic formula. Okay, so let's go ahead and put in this information here. So we have y is equal to minus 1, b is 1, plus or minus the root of b squared is 1 squared minus 4 into a is -1, multiplied to c is 1, all of that divided by 2a, 2 into -1. Okay, so we should always be careful not to make any error at this level, putting in these values in our quadratic formula. Okay, so it means y will be equal to -1 plus or minus the root of 1 squared is 1, -4 multiplied to -1 is +4, all over -2. This gives us -1 plus or minus the root of 5, all over -2. All right, these are the two possible values of y. So we can call the first one y1 to be equal to -1 plus root 5 all over -2. We call the second one y2 to be -1 minus root 5 all over -2. These are our two values for y. Our solution does not stop here because we're not asked to solve for y. We're asked to solve for x. So we come back this way and let's continue here. So we are told that y1 is -1 plus root 5 all over -2. This can just be written taking this -2 up. That means we multiply numerator and denominator by negative, will just be 1 minus root 5 all over 2. Okay, now let's look at it carefully. We are told that y is 5 all over 3 to the power x. Okay, this is the relation that will bring in x. Okay, let's see. If we take now this and put it there, we're now saying therefore that we're saying 1 minus root 5 all over 2 will be equal to 5 all over 3 to the power x. Now, look at this carefully and see. Root 5 is a number bigger than 1. Therefore, 1 minus a bigger number will definitely be negative. All right, and so this expression on the left hand side is negative. How comes therefore that a negative value will be equated to a positive value? Because all index expressions are always positive, no matter the sign of the power. This expression on the right hand side will always be positive no matter the value of x, this power. So we can't equate a negative value to a positive expression. So here we'll say impossible. Impossible. So we don't have any solution with this situation. Now let's look at the other one. Let's look at the other one. When we have y2 is equal to -1 minus root 5 all over -2. Again, if we multiply numerator and denominator by negative, we're going to have +1 plus root 5 all over 2. So y2 is 1 plus root 5 all over 2, which is clearly a positive quantity. Now we are told, or we know, that y is 5 all over 3 to the power x. Now put that there. We are going to have 5 all over 3 to the power x is equal to 1 plus root 5 all over 2. This is clearly possible. This expression will always be positive no matter the value of x, and here we have a positive value. So this expression, this equation is solvable. So now from here to get x, the easiest value for x will just be when we take log to the base 5 all over 3 of both sides. Okay, taking log to the base 5 all over 3 of both sides. Now let's do that and see what we get. We're going to have log to the base 5 all over 3 of 5 all over 3 to the x is equal to log to the base 5 all over 3 of 1 plus root 5 all over 2. Okay, so you can see when we apply the rules of logarithm, this is simply x. Alright, this gives us x will be equal to log to the base 5 all over 3 of 1 plus root 5 all over 2. So we have just this solution. This is the solution to our exponential equation.